Okay, so we've all seen this, right? You give an AI a really tough problem, and it doesn't just spit out an answer. It actually shows you its work, laying out this whole step-by-step reasoning process. It's called a chain of thought, and it looks, well, incredibly human. But how is it really doing that? I mean, does it have a grand plan from the very start, or is it just making it up as it goes? That's the big mystery we're going to unpack today.
And that really brings us to the heart of the matter. When an AI starts to think, is it like a chess grandmaster who's already seen the whole game play out in their head, every move planned from start to finish? Or is it more like a genius jazz musician who just knows the very next note to play, improvising this beautiful melody one moment at a time? Is it a planner or an improviser?
Now, just so we're all on the same page, that step-by-step process, researchers have a name for it, chain of thought, or COT for short. It's the AI literally talking its way through a problem, and it's what makes these models so incredibly powerful. Figuring out how that actually works under the hood is the key to everything. So, to crack this case, researchers knew they couldn't just look at the final answer. Nope. They needed a way to peek inside the AI's mind while it was working, to actually see what it was thinking at every single step of the journey.
And to do that, they built a special tool for the job called Tele-Lens. You can think of it like a super high-tech magnifying glass that lets them look right into the AI's internal state. At any point in that chain of reasoning, Tele-Lens let them just pause and ask the model, hey, what do you really know right now?
And using Tele-Lens, they basically grilled the AI with 3 crucial questions at every step. First, do you know the final answer yet? Second, can you tell me what you're about to say next? And third, any clue how long this whole thinking process is going to take? The answers to these questions, well, they would become the clues that would solve the entire mystery.
All right, and this is where the real detective work kicks in. By looking at the AI's answers to those 3 questions, the researchers started to piece together the evidence and finally settle this planner versus improviser debate once and for all. So the first big clue they were looking for was this. When does the AI actually figure out the final answer? Is it confident from the very beginning, or does that confidence bubble up somewhere later down the line? This graph tells such a fascinating story. That black line, that's tracking the AI's confidence in the right answer over time. And look at it, for almost the entire process, it's totally flat, just hovering around random chance. It basically has no clue. Then, all of a sudden, right at the end, that red bar, bam! A massive, dramatic spike in confidence. The AI doesn't know the answer all along. It has this sudden aha moment right before it gives it to you.
Okay, so the AI doesn't know the final answer from the get-go. But does it at least know the path it's going to take to get there? The next clue was all about foresight. How many steps into the future can the AI accurately predict its own reasoning?
And the evidence here is just as crystal clear. This chart shows how good the AI is at predicting its future steps. It's fantastic at guessing the very next word, sure, but look how fast those lines just plummet. After just 1 or 2 steps, its ability to see the future completely fades. It's not following a map. It's navigating in the dark with a tiny little flashlight.
And that brings us to the final piece of the puzzle. You know, if the AI were a real planner, it should have some sense of the entire journey from the beginning. So the question is, does it know how much work is ahead? Can it predict how long its own chain of thought is even going to be?
The answer here is a huge, resounding no. Just look at these heat maps. They compare the AI's predicted length with the actual length. If it were a perfect planner, you'd see a nice, bright diagonal line. Instead, it's a total mess. There is almost zero correlation. It's like the AI is starting a road trip without knowing if it's driving to the corner store or across the entire country.
So, let's review the evidence. The AI has no clue what the answer is until the very end. It has extremely limited foresight into its own thinking, and it has no idea how long the journey will take. I think it's time for the verdict. All the evidence, it points overwhelmingly in one direction. The AI is not a master planner with a grand strategy. It's a brilliant improviser, focusing only on the very next, most logical step, and discovering the path forward as it goes.
And the researchers themselves came to this exact same conclusion. They found that these AI models operate with what they call a myopic horizon. Myopic as in nearsighted. The AI's entire thinking process is built to support the immediate, local step right in front of it, not some grand long-range plan.
Now, this isn't just some fascinating academic finding. Understanding that AI is basically a short-sighted improviser has huge practical implications for how we use these tools, how we decide to trust them, and how we can make them way more efficient.
So the first big implication is something called the wooden barrel principle, and it makes perfect sense. A wooden barrel can only hold as much water as its shortest wooden slat, right? Well, in the same way, the reliability of an AI's reasoning isn't about its average confidence, it's all about its most uncertain steps, its weakest links.
And this idea turns out to be incredibly useful. Instead of trying to measure the AI's confidence across thousands of steps, we can just zero in on the 5 or 10 most uncertain pivot points. And look at this table. Using Tele-Lens to focus only on those weakest links gives us a confidence score of 0.69. That's a full 9% more accurate at predicting if the AI is right or wrong. It's just a much smarter way to know when to trust the answer.
Okay, the second big implication is a really clever efficiency trick. I mean, if the AI is just improvising step by step, does it always need to go through the whole long song and dance? For simpler problems where it gets the gist of the answer early on, maybe we can just let it take a shortcut.
This is what they call the caught bypass. By teaching the model to recognize when it has a pretty good idea of the answer early on, we can let it skip that whole long chain of thought process. And on some tasks, this happens over 16% of the time. That's a massive savings in computer power.
But here's the absolute kicker. You get that 16% speed up for almost nothing. The overall drop in accuracy is a tiny, negligible negative 0.03%. It's basically free speed, all by taking advantage of the AI's natural improvisational style.
So, we've learned that today's AI is less of a grand chess master and more of a brilliant but nearsighted jazz musician. And that leaves us with one final, really big question to think about. If AI can only really see one step ahead, what does that mean for solving the kind of grand challenges that require true, long-range foresight? Solving those, well, that might require a completely new kind of AI.